Prism down. Cylinder down. Pyramid. Biggest difference between the pyramid and the cylinder prism, how many bases on a pyramid? One, that's it. Okay, only one. Not two anymore, just one. And I will let you guys know, for us anyway in here, that base is always going to be a regular base. What do I mean by a regular base? Griff?
Square.
Could be a square, but no matter what the shape is, if it's regular, what do we know about its sides? All the sides are equal. Okay, so for us, because you're going to see more than a square base right here, all right? So base is regular. You're going to see more than a square base. Now let's talk about, take the base off. Let's talk about the faces. The faces are always what? What shape? Faces are always what? Triangles, always. In a pyramid, your faces are always triangles. And I'm going to make a little more detail than just a triangle. They are isosceles triangles. All right. So no matter what the shape is, the base is regular, all sides are equal, and all the faces are always isosceles triangles. Here's the point I need to get through to you right now. In a pyramid, not one, but two heights. There's the altitude height, and then the slant height, which is on one of the faces. Anybody familiar with the Mission Impossible movies? Anybody? Yeah, I'm sure you talked to your period 2 friends and you're about to know what I'm about to do, which kind of stinks because they blew it. But anybody? Mission Impossible series? Tom Cruise? No? Nothing. He does all these crazy stunts and pretty action-filled movies. Nobody? Mission Impossible, maybe some of you? Okay. To figure out the altitude versus the slant height, you got to get into your Mission Impossible mode. Okay? You need to get into your Mission Impossible mode. So here's what you got to think of with the heights. So here's what you got to think of. Everybody's inside the pyramid right now. Okay? Everybody's inside the pyramid. All good? You are at the very tip of the pyramid, inside, which is called the apex, if anybody wants to reference it. Apex. And all you are doing is holding on for dear life. And you need to get down. And the only thing you have in your pocket is some rope. All right? So you attach the rope to the apex, and you let it drop straight down. All right? So it forms a right angle at the bottom. Everyone visioning this. This right here is called your altitude. That's the height. Everybody good? That's the height. That's straight down. There's a different height. Look on your packet. That says slant height. You guys just told me what shape are the faces. What shape are the faces? The height on those faces is the slant height. See the difference? The altitude is the height inside. The slant height is the height on one of the faces. All good? Yes, no? Okay, let's see if we're really, we know what the deal is here. Let's talk lateral area. What's the definition of lateral area again? Everything but? Okay, so take the darn thing off. What figures are left? Number of triangles left. Times. What's the area for one of them? Come on. How many times have we used this formula? 1/2 base times height. So that's how I'm going to find the lateral area of every pyramid. So look at this first one I gave you here to find the lateral area. Look at the 8 I'm pointing to. Look at the 8. Altitude or slant height? That 8 I'm pointing to. That's the altitude, right? That's my Mission Impossible height. I need to get down from the apex. How many triangles are formed? 4. So here we go. 4 times, let's find the area of one of them right now. So let's take this one right here. What's the base? 12. So I'm going to go 1/2, 12. Can I use that 8? No, that's the height of the pyramid, not the height of this face I just highlighted in green. What is the height? That's your slant height. That's your slant height. How can I find it? Everyone here? Good. How can I find it? I got 8. I'm trying to find. Everyone see the right triangle that it formed.
Thinking about making Kajabi your all-in-one monetization platform? It's okay if you're not ready to commit just yet. When your brand runs...
We got a timer with chill hop music, huh? I'm not. Usually I keep it going every year, depending on what it is. I'm not a big fan of this one. It's like a bootleg. They're just going to give me 10-minute relaxing music. Yep, that's right up our alley. They're just going to keep giving me 10-minute timers.
Thinking about making Kajabi your all-in-one monetization platform? Yeah. It's okay.
10-minute timer for chilling.
Just yet.
What's that music sound like? The chilling music. No. They're going to give me a 15-minute one next. Why don't you relax, all right? This is brutal. Brutal. Whoever, and there's 54,000 people. More people listen to this than watch my video, which is disturbing. 3 times more, by the way. 3 times more. That's disturbing. I can't. We're done. There's nothing going to be nothing I'm going to be able to find. It's going to get me going. We went from Mission Impossible to relaxing. Awesome. Amazing. Thank God this channel exists. Oh my God. Reevaluate your life. Reevaluate your life. All right. I don't know what's worse, this coming up or second period when the next song right after Mission Impossible was We Don't Talk About Bruno. And I was like, nope. My head might explode if I have to hear that one again. All right. So going back here, do we see the right triangle that's formed? Do we see it? Okay. So I can do Pythagorean theorem to find the slant height. But you might have a question when we do Pythag. I got you the 8, my Mission Impossible height. That's one leg. We know we're solving for the slant height, which is my hypotenuse. Any thoughts about this? Right here? Always going to be half the base length. It's always half the base. So we're going to put a 6 squared in there. So the slant height ended up being 10. And there we go. Now we can find the lateral area. So for the pyramid, all the triangular faces, find the areas of them. What do they have there? 240? 240 square feet. Anything good? All right, now same figure. We're going to use the same figure, but now let's find its surface area. So surface area, it's that lateral area we just found plus how many bases? 1. And hey, take a look at what I'm going to do here. I'm just going to put a big B That means the area of whatever the base is. You guys are going to get lucky in the first couple that are all squares, but then I'm going to finish class off with a hexagon base. What do I do then? All right, but it's the area of whatever that base is. So for this one here, we're going to take our 240 and add on that base, which again, you guys got lucky. It's not that bad. How are you finding the area of that base? Calling my first numbers here today. 22. How do I find the area of that base? One job. Where is he? Oh, right. 8? 12 times 12. There we go. Questions? All right, bless you. Let's go back to lateral area for number 1 here. First question I have to make sure we can distinguish between altitude versus slant height. What's the 13 pointing to? That is the slant height, not the Mission Impossible altitude. That's the slant height. That's the height of one of those triangular faces. And there's 4 of them at 1/2 base times height. You're welcome here because I've given you everything. No Pythag needed, I hope. No Pythag needed. Unless you want to find the actual height, but it's not needed. All right, 16. On one of those triangular faces, what are the base and the height? 10, 13. And we get 260 square inches. And then I always get whining and complaining about number 2. Why is it upside down? It doesn't look... Okay, turn your paper. How about that? You don't like it. What's the 7 pointing to? The arrow with the 7. What is it pointing to? Slant height or altitude? Here we go. 23, what's it pointing to? Altitude. Good. So once I do the height of the face, I can't use it. 4 times 1/2 BH. All right, here you go, everyone. We are finding, where is it? One of these triangular faces. Finding the area. What's the base of one of those triangular faces? The base? 6. Base of one of those triangular faces? 7. So we'll go times 7. Now, not times 7 again. We got to do Pythag. 7 squared, the altitude, plus, what do we put in for the other leg? Other leg, not 7 again. Other leg, 18. This leg right here I'm looking for. 3.5. You always take half the base on a square base there. 3.5 squared. Some of you are getting ahead here. You'll notice this is not a perfect square. Oh, sorry. We're not rounding it. What do you get? 61.25. All right, take the square root. Don't round it. And I'm just going to put square root of 61.25 up here. But since I don't want to write down the full decimal. $109.6. Any questions? Going. Surface area. Before I change up the base on you. Surface area number 3, and then I'll change the shape of the base. 4 triangles. Plus the area of that square base. What's 12 pointing to? 12 meters is the 24. Altitude, good. That's the altitude, so I do not want to use it when I plug in for H here. Ooh, what's Pythag going to look here? Be careful. Definitely going to use the 12, the height, the altitude. What am I going to use for the other leg now? Not 5. Oh, 5. Speaking of 5, what am I going to use? 2.5 squared to solve for that slant height. Square root of, didn't leave myself much room. Square root of 150.25. Close it up. Have this over here. $147.6 square meters. Questions? Going? Ready to change from the square base? You guys have been on easy street with the square base. All right, take a look. Now it's a hexagonal base. Still regular. All sides are equal. Still regular. I'm not changing anything. I'm still going to do surface area. But now how many triangular faces do I have up here? Not 4 anymore. 15. How many do I have? 6. So 6 times 1/2 base times height. Plus the area of the hexagon, which is actually the toughest part of this problem. Base and height of one of the triangular faces. Base and height of one. You got everything given to you. Base and height. Here we go. 23. Not here. 8. Base and height of a triangular face. 6, and I gave it to you off to the side. That's 12 plus. Everyone ready? So let me get my hexagon out here. Boom. All right, find the area of that hexagon. So we're going to have to go last unit, right? Last unit. Remember, we did, okay. So big B is going to be equal to 6 of those triangles I can make, right? 6 times 1/2. We already know the base, right? We already know the base. 6. Can I get your help finding the height of one of those? First thing, can you find the central angle there? Central angle, what do you got, Tammy? 60. 360 divided by 6 gives me 60. The height cuts it in half, so this is 30. 60. Ooh, you have a great day. Enjoy it. Don't think I didn't a fresh cut? Yeah. Darn right you did. We're probably going to go right now and get part 2 done. That's a 2-day job right there. 2-day job. I had that thought up for like the last 5 minutes. I was waiting. 6. Now help me find the height. What does the height bisect? Not just the angle, but the base too. So don't use 6 in your calculation. Make sure you're using 3. Shorter, longer, hypotenuse. 3. Shorter. Is the height longer or the hypotenuse? longer. So I have shorter 3. What would be the longer now? 20? Do we not have a 20 anymore? Jonathan. Totally missed that he wasn't here either. Sorry, Jonathan. 23? Lee? What's the height? If the shorter's 3, how do I get to the longer? 3 radical 3. I'll tell him tomorrow too, but I also noticed he did something with that crustache he's been trying to grow out too. It was crusty. We all know that. It was crusty. Poor kid's not even here to defend himself. Probably took him 3 years. Probably took him 3 years to grow that. Whatever that caterpillar was there. So this right here is my B value. If you want to simplify it, 6 times a half times 6 times 3, 54 radical 3. If you want to simplify it, that's the area of the base. What's your deal?
So like on the base, I kind of got 108 radical 3.
What do you have?
108 radical 3. It's double 54. So I don't really know how I got that.
6 times 6 is 36. A half of 36 is 18. 18 times 3, 54. Or you can go 6 times a half.
Shoot, yeah, I forgot to do that.
Yeah, you don't know how to multiply. Yep. Anything else going? One more? And you know how I warned you on Friday, this is how we end every class. Let's put 2 figures together and get after it. Except I'm not getting after it with you. You are on your own or with somebody near you. What's on top? What's on top? What's on top? Pyramid without the what? Okay, so don't include the base then. It's being covered up. Plus, what's that figure? What's that polyhedron on the bottom? Plus the rectangular prism. Do you see all 6 faces showing? Or, no. So don't find all 6. How many do you see? 5 that are showing. And, whoa, because this was a common mistake I don't want you to run into that happened second period. Are all 5 the same dimensions? No, that bottom one is a different dimension. It's not 6 by 3. So don't tell me 5 times these dimensions. All 5 are not the same. Let me know when you're done. I'll sign you off and you can go to the homework. You kids watching at home, I'll jot the answer down real quick so these creepers don't see it, even though they can. There we go.